Hello and welcome to this hopefully short video about printing. As you're creating beautiful results using Python, then at some point you want to be able to print whatever the output is of what you're calculating, and then you need to use print statements. So that's what we're going to talk about today, how you sort of make the print statements readable, and also a bit about how to print output into a text file, for example. And there's also an advanced section about how to create the text tables using Python, but that's optional. Okay, so in the example in this notebook is just how to describe an utility function, but it could be like any sort of function that you want to print. Yeah, so we start with a calculus utility function, then we define it here with two positional arguments, x1 and x2, and an alpha, which is a keyword argument or an optional argument. And then we want to print it, then we use this print statement that you have already seen. But the key thing here is using f-strings to print the values inside of a string. So what f-string allows us to is to use these curly brackets to refer to variables we have already defined and to like format them inside the brackets. You say, okay, I want to show the value of some variable, and I want it to be x1, and then you write the colon, and then you write the format that you want to show this variable in. So this f signals that it's a float, and then you write .4 signals that you want 4 digits. And here you want 3, so you can sort of play around with that to say how many digits you want. So we have x1, x2, calculate a u using this u function we've already defined, and then we just print it using this line and these f strings. You can do that in a loop like this. So then we just have a list of x's, and then we can loop over them and print them using like almost actually the exact same statement, just where we calculate u as a new variable each time, and we insert a new x1 each time. You can make this look a bit nicer because we actually know that x1 and x2 are integers and not floats, because that's how we define them. So you can instead use this d, which just basically just assigns the width of how you want to show the variable. So 2d just assigns an integer of width 2. So you can see there's sort of a small spacing before the 0. That's because it's right aligned if you don't tell it to do anything. So you can see it's moved slightly to the left when you delete it. If you want it to be left aligned, then you need the less than sign, and then it's the exact same. So here you want x1 of a width of 3, and you can see like where it comes in. You have a spacing before, and you actually only have defined explicitly one spacing after, but you can see that Python had made 3 because it has the value, and then it's made 2 spacings because you defined that it should have the width of 3. The reason you might want to do this is because of course x1 could be 10, and then if you hadn't defined that there should be some spacing here, then it would like the x2s would not have aligned. So you can see this gets kind of messy because there's no spacing here. So when x1 becomes larger than 10, so that's 2 digits, then everything looks ugly. And you still have the float argument, but you can also tell it to be left aligned, and you can tell Python how you want the total width of what you're printing to be. So that includes the decimals that you're defining after the dot. So that's the base things about f-strings and printing. I have a lot of like helpful links. So strings have a lot of methods, like making everything uppercase or making everything lowercase, removing leading spaces or removing specific elements. And there's like a list here that you can go through if you need to do some specific string stuff and you think Python may have a better way than sort of defining your own function for doing it. There are also 2 guides on output formatting. The main thing I would look at in these guys is the stuff about f-strings. F-strings are really like versatile and good for printing and formatting floats and other numbers. And it can do a lot. There's also like a concise list of different formatting options. So what you put in here after the colon. If you use this link. Yeah, so if you want to dig more into it, then you should definitely take a look at these kind of things. So now there's a small task then you can try to do, which is just to write a loop that prints the results shown like this. And this is basically just to get you to work sort of with these print statements and alter them slightly. So what the approach you should take is just to go back to these loops, maybe just copy it and then change it to make it look like this in terms of how many digits and the spacing and all that stuff. So yeah, take a crack at it, pause the video, and then I'll show you. Yeah, hopefully now you made a really good loop and have a function that looks close to this, or at least outputs the same as up here. Yeah, so I mean the twerks is just basically that you copy the statement from up here, and then you change the string to look like this. So you want it to be seen as a float with 2 decimals, and you want u to have 4 decimals. That's the important part. Now we move on to printing outputs to a file. So this is how to actually create a new text file with your output. And this is sort of a good way to store output from whatever you're doing. So it doesn't get lost when you try to rerun stuff. And what you do is you use with, and then you say open, and then you say the name of some file, and then when you're running like in a notebook like here, then sort of Python's working directory is the directory where it is currently located. So it will create a file or overwrite a file in the same folder as where the notebook is stored. Yeah, and that's because you're writing right here, so it will overwrite it. You can also read files, we'll look at that afterwards. And then you just call it whatever you want. Here we call it file.ref, so the file you have reference. And now we create a list, a loop, create a loop, and then we do like a lot of the same stuff we have just done. We just create, instead of printing, we create a string variable with the string we want, and then we write it into the file, and then we add underscore n, not underscore, slash n, which gives a line shift, which automatically happens when we use these print statements in a loop, but does not automatically happen when we write into a file. So if we do this, then we can see that we have written the statement. I can also maybe show you that if I delete this and then I open it, then there's nothing in it. But then I run this line of code, and then you can see that Python has recreated it. And this was the output we wanted. Yeah, you can also read lines from a file in the same manner. Then you just use R for read instead of W for write. And what this, so you're still using with, open, you just, and then the name of the file, then you just use R, and then you still give it a name, and then you can load the lines into a variable by using read lines, and then it will sort of be stored as a list of each line in the text file, and then you can do it and print each line. And if you're like super good at writing LaTeX tables, then you can also sort of use this to just write LaTeX format. There's a small question. Wasn't the loop inside the with operator strictly necessary? So was having this loop inside this with operator, so with the spacing, was that necessary? Think about it. The answer is no. Sort of leading question. You could also just write it like this, because you define these lines as its own variable, so you sort of already read what you wanted to read from the some file text, and then you can run like this, and it's the exact same. So this is just sort of define what you have within the with open is only the file ref that's sort of local. So you wouldn't be able to have all of this outside of the with. Then it will not know what the file ref is. But you could have the loop outside. Yeah. So that was actually the video. Main things you should learn about printing. There's an extra section, which is quite long, down here about how to write LaTeX tables. But you should only view it if you want to, because it's not really directly relevant for the course, because you won't be making LaTeX tables. But in the future, I imagine a lot of you will want to use Python to do something that you want to put in some form of a paper or assignment. And then you usually want it as a LaTeX table, and then it's nice to know. So yeah, I'll go through the code here. Feel free to skip it if you don't care about LaTeX, or if you know in your head how to sort of write the LaTeX code you want. This is sort of a nicer way, an easier way to do it. Yeah, thank you for watching. For those who don't like LaTeX, now I'll quickly go through this code. Yeah, so this is how to make LaTeX codes. We need pandas, which you might not be that familiar with yet, but it's sort of it's a nice way to store data frames, but it also has the functionality of being able to so data frames are like Excel sheets basically, but it also has the functionality of being able to print these data frames as LaTeX tables. So if you remember, we have this list of x1s. So what I want to show you here is just to sort of do some of the same stuff as this, but instead of printing it into a text file, we print it into a LaTeX table. So we have the list of x1s. We create a list of x2s, but we want it to be constant. So we just create a list of 3s, printed down here. And then we create a list of the u values, which is just calculating the u functions for each element of x1, where x2 is sort of constant. But yeah, zipped it, sort of showed explicitly. Yeah. So we have a list of our x1s, and a list of our x2s, and a list of our x3s, and then we can put it into a data frame like directly by writing pd.dataframe, which creates an empty data frame, and then we can fill it up using from dict, so from a dictionary, and then we can sort of, the dictionary we want is just each column. So the name of each column is the key, and then the value is this list of values. So there's the list of the x1s, and the list of x2s, and the list of u. And we can sort of, straight from the go, we can just print that into a LaTeX table. So this is the exact same, just in a LaTeX table formula or in a tabular formula, which you can put into a LaTeX table. This is the direct way to do it. It's not gonna be that pretty. There are no like lines or anything, and we have like way too many digits on U. But that's the way you do it directly. The first thing, so now I'm gonna show you how to make it a little bit prettier. First thing is we can hide the index, because that sort of automatically comes with counting 0, 1, 3, 2, 0, 1, 2, 3, 3. You can just write dot hide index, and then you don't print the index. We can also reformat U. So here I do it by directly changing U in the data frame. So we have U up here, and then I say, okay, now I want U to be equal to the old view, which was the floats, but I want it to be formatted differently. You'll learn exactly how apply works later. Here so I give it new digits and I say utils. So they get 2.711 utils for these corresponding x1 and x2. You can also write LaTeX math directly into the data frame, so we rename the columns x1 and x2 and also U to have new names, which looks horrendous here, but in a LaTeX code it will look good, so you just have the one as a subscript. And the same here, x1 and x2 will have like subscripts. Instead of saying x1, it will be x small one. And then we can also add a first column, which is just the index. We can sort of recreate the index to give it some information. Here we just call it scenario A, scenario B, scenario C, D. And then we can print it. And now, I mean, here it still looks bad. It does so anyway because it's LaTeX code, but if you put it into some overleaf or a LaTeX operator, then you could sort of make it look good, or print it, and it would look good. You can also play around with the column formatting. So here it's sort of the default is just that the index is left aligned and the integer values are right aligned and string values are left aligned. So that's what Python does automatically, but you can sort of explicitly say, okay, I want the index to be left aligned, and then I want that to be a vertical line, and then I want it to be centered the other columns. I also usually add H rules to be true, and then Python adds this top rule, mid rule, and bottom rule, which sort of creates horizontal lines and just makes for a more nicer looking table. You can sort of print this and just copy it into your LaTeX code if you want. The nicer way is sort of to save it as a file and then reference it in your LaTeX code. The way you save it as a file is, instead of just writing this out, which sort of creates this string, then you can write buff equals to, and then somewhere you want to store. So here I just write the name, and then it sort of saves it within the folder where the notebook is, but you can also write a folder path. Yeah. So making a LaTeX table like this is extremely versatile once you get the hang of it. There's also a link to some more options on the documentation. So you're sort of not relying that much on packages and showing. I mean, there are some packages which can sort of do regressions for you, and then it can actually output some LaTeX code, but it's not very. Easy to sort of make customizations, and it's relatively easy to make customizations here because you can sort of write LaTeX code within the values, and you can move stuff around the way you want it. You can also use the multi-column features of pandas, which you haven't learned about them yet, but they can sort of make, if you want, tables with multiple columns, which are sort of, sometimes they overlap, sometimes they don't, and stuff like that. Yeah, that's a bit more, even more advanced stuff. And you should note that it can also be cumbersome because there are so many ways you can switch stuff around, and sometimes requires some tinkering to get it work the way you want. My best advice is trial and error, to sort of get what you want, and also don't get bogged down if you don't have like the perfect table. It just needs to be readable. That's the most important part. And then second important part is it has to look good. Yeah, that was all. Thank you for watching.